So we got this 2013 Nissan Altima here with a 2.5 liter. And basically I've got this car now. It came from another shop, and I sort of get to do the diag to see if it needs timing chains or not. So the story sort of goes like this. Woman picked up this car, she had purchased it, and wherever it got safetied, lady drove the car, check engine light came on, brought it back to the place that it got safetied at. They said it needed a camshaft sensor. So then they put a camshaft sensor in it. And then she took it, and light came back on, brought it back, and they said, oh, it needs the other camshaft sensor. So got another one. And then she took it, and light came back on. She brought it back, and they said, it needs another camshaft sensor because one of them that they put in was bad. So they put one of those in, and she left, and the check engine light came back on. So then they said, well, we think it needs timing chains. And so I haven't actually talked with the mechanic that worked on this thing. This is just what I'm being told. So, but anyhow, now I get to look at it, and I scanned it, of course, and it had a P052B fault code in it, which is camshaft A timing over retarded. So I then graphed both intake and exhaust camshaft sensor signals, and the exhaust cam was responding nicely, but the intake cam was erratic. It was jumping from 0 to 30 degrees like crazy, and I was like, oh, that's funky. But the car runs fine. It's not like it's chugging or like running really crappy or anything like that. So my theory of what's going on with it is that one of the oil control valves, there's either air somehow getting in, like it's getting aerated, or the valve's getting stuck, or something's happening to the valve where it's cutting off oil, and somehow there's air that's getting trapped in the controller, and that air compresses, and the controller actually gets to allows it to chatter, move back and forth so fast that it sort of skews the readings. But I don't know, I'm gonna try to pull these solenoids out. I did a resistance check on them. They're all good. The spec is 7 to 7.7 ohms, and they were all 7.4, 7.2, or yeah, all 7.4. So I also went through and I just double checked a bunch of work. I went over some of the basic stuff. Just resistance values and voltages. I just checked for shorts and 5-volt references and grounds and stuff like that on camshaft sensors. You notice the one has a broken connector on it, and it isn't actually secured. It can slip off, so that was a red flag right away. But I had somebody hold that in place while I was testing it just to rule that out of the equation, but that's definitely got to get fixed. And we did just swap the sensors from side to side to see if it chased it, but it didn't. So yeah, basically at this point, I'm just fighting to get these solenoids out of here. So they're stuck in there. This is the first time they're coming out. And this is bolt out of one of them, and you can see steel bolt in an aluminum housing, and it started to pull the threads a little bit. So I have to be careful with those. You have to put them in and pull them out, get some oil on them or something to try not to muck all the threads up on it. But managed to get that out. Now I'm just struggling to get this these solenoids out. They're probably going to be stuck in there pretty good. Yeah. All right, so yeah, I got this oil control valve freed up. It was stuck in there. I just put a gear clamp around it so that I had something that I could drive off of. You don't want to hit this because it's solenoid, right? So there's a big copper winding that's inside of there, and if you hit it at all, it could compromise the circuit inside, and then it's not going to work. So You can just stick that on there and give it a couple whacks, get it to move. That's it. So we tried taking these out as carefully as we could. They're pretty cheap design. This is the solenoid portion, and then this is the actual oil control valve portion. So this piece just sits inside of here, and then you can see they have something that just sort of crimps. It folds the top of this over to pinch, keep this on, keep it locked. And of course you get a bunch of corrosion that gets in there, and you try to pull it out and it won't come out. So what happens? Well, it just folds this crimped portion back out and they separate. So kind of sucks, but I feel like it's just a really cheap design. There's no way to get around it.
Replace all three?
Yeah, I'm going to replace all three. I did take a look and see, and there was like a bit of, I wouldn't say dirt, but you could see like grime and stuff that was in there. So, I mean, they need to be replaced anyways. So, yeah, I'm debating on whether or not I want to check the timing chain and just rule that out, because really there isn't much else. There was one other step in the diag, and that was to check the oil supply on the camshaft itself. There's a passageway through the cam that goes to the controller that's on the end, the gear, the phaser. So that could possibly be plugged up, but yep, basically just gonna change those and
go from there.
And go from there. Okay. So basically we're just gonna be installing some oil control solenoids today on this Nissan. I think it was a 13 Nissan Altima with a 2.5 liter. As you see in the other video, they're located down at the bottom of this cover. There's 3 of them. 2 of them control the intake cam, variable valve timing controller, and then 1 controls the exhaust side. So we're gonna go ahead and change those. In order to get that mount out and stuff, you have to take quite a few things off. I'll just give you a little rundown on what you have to take off. Start by removing the coolant jug. It's just a 10 mil, and then literally leave the hose attached. Just undo it from all these clamps and set it over there. Then you have 1 bracket on the top, which is this guy right here. So before you unzip all the bolts out of that thing, stick a jack or something underneath of the engine, because if you undo all those bolts, the engine's going to drop down, right? So we want a way that we can move the engine up or down and position it where we need to. I can roll the jack forwards and backwards to move the engine to get the bolt holes to all line up. So that's a super important thing. And then once you get that off, you can take that other giant bracket off. Couple bolts, 2 10 millimeters for grounds, and 18 millimeter bolt that goes through here for this dog bone engine mount. Kind of sucks. There's a 18 millimeter bolt that runs down through there, but you can't get it out because the strut brace is in the way. So I'm gonna try to take it out without removing the wiper cowl. 2 13 millimeter bolts on each side, and then a bunch of those plastic clips. So I got all the plastic clips out right now. I'm hoping I can just zip the bolts out now and just slide it out. That would be sweet. But you know, I'm sure there's probably something stupid that's holding it in. So, and then, yeah, once, really the goal of taking this out to get this out is so I can move this. This thing gets in the way, or actually, sorry, the lines get in the way of removing this thing. I did recover the air conditioning system, pull all the refrigerant out so I could take that line off. And that's gonna give me some more room to hopefully swing this thing out. I might be able to do it right now, but it's just not quite. It'll be nice to get this out of the road too, because this cover has to come off. So anyhow, see if I can get that strut race. Looks like we got a couple 10mm bolts to take out. That's sweet. Just goes into the, it's like a drainage tray that sits underneath of there that this strut brace bolts onto. So I can understand that and see why they do that. Okay, so when you get the strut brace off and you take the 18mm bolt out to get the dog bone piece out, now I just jacked the engine up a little bit to give myself a little bit more room, and then all you got to do is give her the old flipperoo, take her out. All right, so we got this piece off now. We got to change that solenoid.
You also want to talk about the timing chain now?
So as far as I read in the service manual, there's no marks on the actual case on the back, but there is painted links. So you have to line the links up with the crank and the two cams, and that will show you that it hasn't skipped any teeth. And then I don't know how you would check for like timing chain stretch. That's the only thing. Like if you had, the only thing I can think of is if you like get an oscilloscope and graph the cam crank correlation and check it that way. But like anything that I've ever worked on in the past, as far as like this car goes, and the reason why I don't think it's stretch timing chains is because it doesn't have a cam crank correlation fault. It has an issue with the exhaust cam variable valve timing signal. So this cam sensor is reading what this is doing to the camshaft, and if one of those oil control valves is screwing up and causing this thing to act erratically, well, that sensor is going to pick that up, and you know the readings are going to go out of the program parameters. It's going to set a fault code for it. So there's this oil ring here, and it's super important. That right there is your oil feed that goes from the block into the cover where those oil solenoids are. Come look at this cover. So these oil solenoids, oil comes in through here, goes to the solenoids. The solenoids then open and close to direct oil through these passageways right here into this, which then goes into the variable valve timing controller and feeds oil inside of the controller to push against spring pressure to actually change the gear's position, sorry. And this O-ring right here that seals in between the bridge and the block is super crucial. If this thing is ripped or missing, what's gonna happen is air is gonna get in there, it's gonna aerate the oil, and guess what's gonna happen when that oil pressure tries to build inside the controller? It's now going to, all that air is gonna compress, and it's gonna cause that variable valve timing controller to chatter. It's gonna cause it to give an erratic signal, possibly give you variable valve timing controller faults, stuff like that. So watch when you take this thing off. If you take this thing off, like this one, now it was stuck in there when I took this off previously, but I took it off to take a look at it, and I just stuck it back in, but it fell out when I pulled the cover back off. So luckily it didn't fall down into the timing case, but it's something you got to pay attention to, because if that thing falls out and you don't notice and you put it all back together, guess what? You're gonna have problems. So funny story about silicone. I'm scraping this off, and it just reminded me of this time that I had to take a car to school. I was working for Toyota at the time, and they give you a rental car to take to school. And I was bringing it back or whatever, and I go to pass somebody, and check engine light comes on. So I'm like, oh geez. Didn't have any drivability issues, seemed fine, but whatever, come back. And the engine had just been torn down, well, partially torn down, the cams are out of it and whatever, and put back together for some weird reason. And I was like, oh geez, was it my fault? Was it something that I did? But turns out the girl that was working on it ended up putting way too much silicone on the piece that she was gluing back together. And when you squish it down and it overflows into the side like that, well, there was so much that it like squeezed out and then eventually just kind of drooped in and like hardened all around, and then it was free, it was floating around. And I think it ended up getting caught up in like the variable valve timing controller. I can't exactly remember what it got caught up in, but it got caught up in something that, you know, something couldn't work right, and then it was setting fault codes. I was like, oh, it wasn't even anything I did. And then she was like getting all defensive, like, well, it wasn't my fault. Like, yeah, it was.
So what you're saying is don't overdo it on a silicone
Yeah, what
seal.
I'm saying is, you know, less is more. You really don't have to put a whole lot in here. You just get it all clean, and then you just put a little bit around and just smear it around. You know, experienced guys will know what I'm talking about. But for you young bucks out there, don't go too crazy. You just need enough to just cover the surface. Just smear it around with your finger, and that'll do the trick. Alrighty, so we got our good old solenoids here. And I just oil everything up before it goes in. Just like that. Make sure that those bores in there that everything slides into is nice and clean. Don't have a bunch of dirt and corrosion hanging out in there. And yeah, I just oil it up before it goes in because there's a pretty decently tight fit, and you don't want it to like scuff anything. That would be the last thing I want, is it have a little metal shaving come off or something that's stuck in the plunger. Give you problems. Damn, they gave me a bad part. Okay, so we got the that cover all set up and cleaned up, and we got solenoids installed in it. Next thing we got to do is clean off this side, just on the I guess it would be the front cover case, I believe. Yeah, because like this whole sub case gets bolted to the head, so we got to clean all this silicone off. I think what I'm gonna try to do is stick like a rag in there so that I don't want silicone pieces and stuff falling down into the timing chain tensioner and down in there into the case. So I'm gonna try to protect it the best I can and then go at it with this nice rusty razor blade. Didn't think I was actually gonna use a rusty razor blade, did you? Yep. Hey, see, I didn't even want to put that much on there. I put too much on. Alright, so once you get your cover back on, start your bolts and snug them down. And then I'm actually going to look up the torque spec here in a minute. And there may be a sequence on how these bolts are to be tightened in a certain order. And I'm going to follow that. Any engine stuff that I do, as far as covers, valve covers, even spark plugs, I like to torque all that stuff. I know a lot of guys just like to crank spark plugs in, and you know, sure, nothing really bad happens, but you never know. I like to torque stuff that goes on the engine. So we're just doing a little resistance test on the wiring here. So we have 3 connectors for our 3 solenoids. And then basically you got 1 power feed that branches off into a parallel circuit to all 3 solenoids, and then coming back out of the solenoids to the PCM is the ground side control. And you have 3 different wire colors for that. So you got brown, you got light blue, and you've got yellow. So the light blue one is for the intake valve intermediate lock control. The brown one is for your exhaust valve control, and the yellow one's for intake. And like I say, so those colored wires go to the PCM, to this brown connector. which is, I believe, located the second one down. There's a black connector on top, and then it goes brown and then gray. So yeah, I just took the this thing off, and then it's a bit of a tricky thing to get this off. You cut the zip tie, and there's two little tangs here that need to be pushed aside, and then this whole thing slides up and off to gain access to the wire colors in the back. But so yeah, I've just got it back probed in there right now to brown. We can see we've got 0.35 ohms. Now, I will warn people, sure, it's a quick test, but the real proper way I've learned to check wires is to load test them. I actually use like a light bulb and run power through there, because if there's only one strand left in that wire, it'll still test and say you've got good ohms. So if you really want to load test it and check the wires and do it properly, yeah, you got to load test it, but I'm just giving it a quick check. I doubt the wiring's bad. I just wanted to make sure there wasn't something that was shorted out somewhere or something weird like that. I gotta cover all my bases. Well, we got it all back together now, so I've put the wheel on it, and actually I'll clean all the oil off the engine first and get that looking all pretty, and then put that shield on, put the wheel on. Engine light's off right now because I had the ECM connectors off, so it wiped the memory out of it. But I'll just go in with scan tool, make sure everything's cool, take it for a drive, and make sure that no lights come back on. Another thing I'm going to check is the trip logic detection, see if it's a 1 or a 2 trip logic, so that you don't take it for a drive and be like, yeah, no light, and then give it back to the customer and find out it's a 2 trip logic, and then the customer drives it and the light comes on.